Hi, my name is Celestina and I'm a student of La Trobe University. Today I'm going to be talking about ghrelin. So ghrelin, or as it's more commonly known, the hunger hormone, as its name suggests, is involved in stimulating hunger in humans. In doing so, it helps maintain energy homeostasis. However, that isn't its sole role in the body. It's also involved in numerous other functions, including the reward process, mood, memory and learning, stress response, gastric motility, glucose homeostasis, immune function, cardiac output, and bone formation. In this presentation, I'll be identifying its place of synthesis and secretion, the mechanisms for regulation, and its cell signaling pathways that are activated. So, as there are numerous pathways, only those associated with endocrine and gastrointestinal systems will be covered. In addition, the ghrelin function of an individual with a gastrointestinal disease will be reviewed to identify how the altered ghrelin function presents. So, during the fasting state, in response to a lack of contents within the stomach, the ghrelin secretion is stimulated. The secretion is a neural stimulation and it travels via the sympathetic nervous system. After we have consumed some food and our stomach is no longer empty, the stimulus is removed and this halts the secretion of ghrelin. Ghrelin is primarily synthesized and secreted by the parietal or oxytonic cells of the stomach. It is secreted as its inactive precursor, progrelin. When it interacts with the enzyme ghrelin O-oxytransferase, or GOAT, a series of reactions is catalyzed where it acsylates into acylghrelin. Now, this product, acylghrelin, can now bind to its target receptor, which is the growth hormone segregate receptor. Apologies for pronunciation, GHSR1A. Now, GHSR1A is a G protein coupled receptor and it can be located within the central nervous system or peripherally throughout the body. Now, its primary destination in respect of its function in maintaining food intake and energy homeostasis is the hypothalamic neurons in the acute nucleus. More specifically, it's the orogenic neurons expressing NPY and AGRP. Now, these hypothalamic acute neurons are also the same site for the production of growth hormone releasing hormone, which stimulates the pituitary gland to release the growth hormone, which is a major endocrine hormone primarily responsible for growth. So ghrelin has been shown to actually produce the same effects as growth hormone releasing hormone on the anterior pituitary gland. That is, it can stimulate the release of growth hormone on its own. Thus, in doing so, ghrelin not only can help maintain our energy homeostasis, but it can also help with the synthesis of different proteins, which helps in, say, muscle growth. Now, gastritis is a gastrointestinal disorder where chronic inflammation actually damages our gastric mucosa. This damage will then lead to destruction of our parietal cells, and as mentioned earlier, this is the site of our ghrelin production and secretion, which if the cells have been destructed and damaged, they're not going to produce as much ghrelin. That reduction in our ghrelin levels is then going to reduce our appetite, which is why a lot of individuals with GI disorders do have a loss of appetite. Now, if it is left untreated, it can actually start wasting away at our body tissues as the body is seeking other sources of energy if it's not getting it from the food that we are consuming. Now, this is the case for a lot of elderly people, like as their bodies naturally start deteriorating with age, it's actually shown to impact the parietal cell's ability to secrete ghrelin, which is why a lot of the elderly do end up with a lack of appetite. Okay, thank you for listening.